Hello everybody, I'm Utsav Bhowmik. I have completed my physics honors from Calcutta University and then studied my BTech and MTech in radio physics and electronics from the same university. After securing first rank from the university, I availed a DST inspired fellowship from Government of India and went on to study PhD in atmospheric physics from the Indian Institute of Tropical Meteorology, Pune, affiliated to Savitribai Phule Pune University. The topic of my expertise is radar meteorology, and I have studied the small scale cloud and rain formation processes over the Western Ghats and how it is entwined with the orography of the region, the large scale forcings, as well as the lightning propensity of the study region. I was associated as a project scientist in the institute from 2018 up to 2021 and participated in numerous field campaigns. I have chased the storms through the lens of radars. I have archived those datasets, I have graded those datasets and compared them with satellite and reanalysis data to obtain scientific information that have been published in peer-reviewed scientific journals of American Geophysical Union and its likes. I have participated in numerous um, uh, conferences and seminars and have earned accolades for my presentation, both scientific and oratory. Uh, Before going for my PhD, I was teaching as an assistant professor at the Heritage Institute of Technology. I was teaching the students solid state electronic devices and signals and systems. After my stint with the Indian Institute of Tropical Meteorology, I was teaching as an assistant professor also in the Amrita Vishwa Vidyapeetham Chennai campus. I was teaching principles of electronics and electrical engineering. I had taken many projects regarding solar cell and renewable energy and electrical vehicles. After that, I was associated with Swiss Re Bangalore. Swiss Re is a reinsurance company where we studied the likelihood of the cyclones hitting a particular property, the intensity and the severity of those cyclones. By studying these, we could guide the underwriters as to what shall be the um, premium that they should be writing for these properties. So today I'll be going to talk about light. So light is very essential in our life because light helps us see the world around us. Basically, what is light? Light is an electromagnetic energy, electromagnetic form of energy. So here, let's consider this diagram. Let this be the x-axis. Let this be the y-axis. And let this be the z-axis. This is the origin. Now, this is one wave traveling along the x-axis. Supposing this is the electric field. This is traveling along the x-axis. Now, let there be another wave that is traveling along this wave is traveling along the y-axis. This wave is traveling along the x-axis. See, along this axis it is traveling, along this axis, like this. And this wave is traveling along the y-axis. So, perpendicular to these two waves, this is the z-axis. So the light ray will travel in this direction. So it is electromagnetic wave. It is an energy. So basically at one end of the spectrum we have the X-rays. At one end of the spectrum we have the gamma rays. In between, from 400 to 700 angstrom units. 1 angstrom is 10 to the power minus 10 meter. So from 400 to 700 angstrom is the visible zone. We get violet to red. Red has the maximum wavelength, violet has the minimum wavelength. So we'll come to these topics later. So basically this is light. Light helps us to see the world around us. Okay. So here, Let us consider what is wavelength and frequency. Supposing this is a wave. A wave is composed of a crest, C-R-E-S-T, and a trough. And again a crest, and again a trough. Okay, so this way the wave propagates. So the distance between one crest and a trough is a wavelength, denoted by lambda. This sign lambda is wavelength. So here the location is 0, x-axis is 0, and it is trying to move upwards. Here also the location is 0, and it is trying to move upwards. So the position and the phase of a vibrating entity, when they match consecutively, the distance between them is the wavelength. Okay. 1 by wavelength is wave number. Now, c is the speed of light, 3 into 10 to the power 8 meter per second. The relationship is c is equal to nu lambda. Now, what is nu? Nu is the frequency. What is frequency? Supposing in 1 second the number of waves crossing a point. Supposing this is a point, or this is a line, say AB. The waves are traveling. So supposing this crest is crossing this line at t is equal to 0. Supposing at t is equal to 1 second, such crests have crossed, some 5 crests have crossed this point, this line A. So in 1 second 5 crests have crossed, or 5 trough has crossed. So frequency is 5 hertz, or per second 5 waves per second is 5 hertz. A is said after the name of the scientist, hertz. So this is the frequency nu, or f. C is equal to f into lambda. So c is the speed of light, f is the frequency, and lambda is the wavelength. So for light, one property that remains constant is its frequency. The speed might change, the wavelength might change. Okay. So today we'll be focusing more on what is known as refraction of light. So light travels in a transparent medium. So say this is medium 1, this is medium 2, this is water, this is air. We all know that water is denser than air. So when light travels from air to water, there is obviously a bending of light. Why? Because the wavelength of the light changes, the speed changes, the frequency remains same. Okay. So supposing we take an example. When you dip a pencil in a beaker, you see the pencil is broken. Actually, it is not broken. It appears to us that as if the ray of light, the pencil is broken. So supposing, let me do the construction. It will be easier for you to understand. So this is the beaker. So supposing this is the pencil. Okay, this is the pencil A, B. The point it touches the water is B. Here it is O. So here we draw a line. So when the ray of light, is very important, the direction of light. Okay, so this is basically the pencil. Okay, so here there is no direction. Now when light moves from this medium to this medium, okay, so this is the ray of light that is moving from a denser medium to rarer medium. This is the point of incidence, and here This is the angle of incidence, I. When light moves to the rarer medium, it diverges away from the normal. This is the normal. It diverges away from the normal. I'll come to these points clearly. 0, A, B, O, O to C, C to C dash. When it diverges away from normal, you will see the light ray will appear to come from this point, and the pencil will appear to be broken up to here. So O dash. So actual pencil is O A B O, A B O, but it will appear to be broken at the point B, and it will be O dashed. Also, in the swimming pool, you see the water to be elevated up to a certain level. This is due to the refraction of light. So, today, these are the laws of refraction that I'll be enumerating. Supposing, let us consider a glass slab. This is a glass slab. A, B, C, and D. A ray of light is coming here. L, L dashed. At this point, we draw a straight line. It is called the normal at the point of incidence. Let us name this M, N dash. Okay. So the angle the incident ray makes with the normal is the angle of incidence. In the glass slab, it will be bent a little bit. It will be bent a little more towards the normal because it is a denser medium. The speed will slow down. This will be the angle of refraction. The refracted ray making an angle with the normal is the angle of refraction. Alternate angles, this is also angle R. And again here, when it emerges out of the glass slab, this angle is again I. This is emergent ray. L, L dash, L double dash, L triple dash. Okay. So I is the angle of incidence. R is the angle of refraction. Okay. So the laws of refraction. Now we enumerate. Law number 1. The angle of incidence and the angle of refraction are in opposite side of the normal. See, this is the normal. Angle of incidence is opposite side of angle of refraction. Point number 2. The incident ray, this is the incident ray. The incident ray, the refracted ray, and the normal drawn at the point of incidence all lies on the same plane. And the incident ray, the refracted ray, and normal at the point of incidence lies on the same plane. Now, very important topic. Supposing this is medium 1 and this is medium 2. This is air, medium 2 is glass. So, the third law is the sine. Sine means this is the triangle, this is the angle theta. A, B, and C. Sine theta is perpendicular by hypotenuse. Some people have perpendicular. BA by hypotenuse, BC perpendicular by hypotenuse. Okay, this is the meaning of sine. So sine of angle of incidence in the rarer medium by sine of angle of refraction in the denser medium is a constant for a given pair of medium 1 and 2, and is referred to as the refractive index Ri of refractive index of the second medium with respect to the first medium. Now supposing light has a reversible property, when it is moving this way, it is sin R by sin I, that is mu 1 2. So sin I by sin R is a constant. So these three are the laws of refraction. Thank you.